we go. Lesson 6-4, let's talk rectangles today.
Whoa, that was cool. That little transition.
A rectangle is a parallelogram with 4 right angles. Everything that's true about a parallelogram is also true about a rectangle, because a rectangle is a parallelogram. Is a parallelogram necessarily a rectangle?
No.
No. Okay? So not everything that's true about a rectangle is conversely true about a parallelogram. But by definition, a rectangle has the following property. Tell me what you know about a parallelogram that we learned last week and went over yesterday. Thomas.
Opposite sides are equal.
Opposite sides are equal. Yes, they are. Yo.
Opposite sides are parallel.
Opposite sides are parallel. Yes. What else do we know about a parallelogram? Hummel.
The angles add up to 360.
Yes. What else do we know about a parallelogram? Chase. Yes. What else do we know about a parallelogram that we learned? Hyam? Okay. Thomas?
Opposite angles are
Opposite angles are congruent in a parallelogram. What about consecutive angles in a parallelogram?
180.
They're supplementary. They add up to 180. Very good. Well, a rectangle is a parallelogram with 4 right angles, so what's true about it? All 4 angles are right angles. Think about it. If one's 90, its opposite is 90, and they're supplementary, which means the consecutives have to add up to 180, so if they're 90 and 90. Opposite sides are parallel and congruent because it's a parallelogram. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other. Because it's a parallelogram, all these things are true about a rectangle, because they're also true about a parallelogram. Okay. Parallelogram, 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 parallelogram. Not necessarily a parallelogram. Okay. Well, let's see if there's anything else that we should know. Give everybody a chance to resume the recording. Here we go. Rectangle. Let's find some other properties that are true about rectangles that are different than what's true about parallelograms. Suppose we call this rectangle D, A, V, and E. And suppose we drew in the 2 diagonals for Dave. So if we draw a diagonal DV, can you guys all see that we form triangle DAV? And when we draw diagonal AE, we form, amongst other things, we form triangle EVA. Say what? So triangle DAV and triangle EVA. Guys, what do you know is true so far?
They're all congruent.
What's congruent?
DA and EV.
DA is congruent to EV because opposite sides of a parallelogram are congruent. DE is congruent to AV. Yes. Let me see if I can do this. Remember, we're dealing with triangle DAV. DAV, EVA. So you guys told me that DA is congruent to EV. Yes. Why? Well, if it's a rectangle, guys, what has to be true about the...
90-degree corners.
Mm-hmm. Yeah, all the angles are right angles, so therefore this has to be a right angle. And this has to be a right angle. And all right angles measure 90 degrees, thus they are congruent. Why? Because it is.
Well, because because it's parallel. It's a parallelogram. And then if you bisected it, it would be the same segment.
Hummel, that's some interesting thoughts. Unfortunately, you can't back them up with a geometric fact, so I can't use it.
I was confused, but I know I'm right.
AV is congruent to AV.
Why is AV congruent to AV, Chase?
Reflexive.
Ah, these are reflexive. They're the same side. Hey, what do you guys notice about these two triangles? Why? Yeah. So by side angle side, these two triangles are congruent. Therefore, what's true about DV and EA? Because? CPCTC. Corresponding parts of congruent triangles are congruent. Excellent work, guys. AV is congruent to AV because they're reflexive. The angles are congruent because they're both right angles. So the triangles are congruent. You guys already told me this. Side angle side. Filling in the notes, that's where SAS goes. And you guys just learned a theorem about the diagonals of a rectangle. What's true about the diagonals of a rectangle? They're congruent. If a parallelogram is a rectangle, then its diagonals are congruent. You did tell me,
I knew.
but you couldn't prove it to me.
I
Well, we can do proofs in this section,
Like on the test?
no, in this, like,
There-
Trimester.
Yes. Not as much as we did last trimester, but there will be some proofs though. You got. Wait a minute. Who said they just take proofs? And you guys, guess what we just did together?
can't figure
A proof.
Write it down.
why. Like, I know it's congruent to something, but I can't tell you why.
Okay. So that's what we got to work on. Not a lot in algebra 2, maybe a little bit in pre-cal.
yeah. It's algebra 2, mostly, like, numbers.
And variables, yes. And
I hate, like, there's a lot of word problems.
can be. That's what we're supposed to do, though, is make you guys think and utilize your mathematical skills.
I like doing a lot of numbers because it makes me look smart.
That's the only thing I got on that slide. Good. Okay. The converse of theorem 6-6.13 is also true. Remember, the theorem said if a rectangle is a parallelogram, then its diagonals are congruent.
So,
What will the converse of that statement be?
the diagonals of a parallelogram.
Are congruent, then the quadrilateral is
Wait.
parallel.
If it's a parallelogram.
I think it's like
Parallelogram are congruent,
if
then
the
the
two
parallelogram is a
bisects,
rectangle.
the two bisects are congruent, then
If the diagonals of
figure
a
is
parallelogram are congruent, then the parallelogram is a rectangle.
How many theorems do we have in this chapter?
Well, we're up to 14.
What is our test?
It'll be before spring break.
Will it be like multiple choice or?
I am thinking part of the test will be multiple choice, and you will take it on the classroom clickers.
Oh, online.
I don't know what that is.
how are we gonna take it
It's a
online?
clicker
We're
and
gonna
like
take it in
the
the lab.
lab will come across and you'll put like it has like A, B, C, or D on the clicker or whatever, and then it'll say like A, B, C, or D on top of the answers, and you just click it and it'll.
Oh, kind of.
Wait, do we get like remotes or something?
Yeah.
Yes.
We did those in Mr.
We all
Davis.
work at We did that in Mrs.
That's the
All right. Open your book to page 422. Let's work on to check your understanding problems.
Miss McClellan.
Mr. Casey, what about
What? Did you hit your head at practice last night?
Well, he hit
Because you already asked me that.
me with that.
I didn't hit him in the head though.
Can you give me 5 minutes?
Yeah.
Okay. You can always just stop on your way to lunch, can't you?
No, but then I'll be last because we're already last anyways. And I hate being last.
Oh, so it doesn't really matter if I let you go early because you'll be last anyway.
No, we're not all the way in the last. We're almost. See, there's a difference of like 10 people.
Oh, 10 people. You know, if there'd be a difference of 20, I might go for it. But if it's only 10, we'll just say that's all right.
Okay, maybe.
Okay. Everybody got your book up into 422?
Yes,
Okay. An X brace on a barn door is both decorative and functional. It helps to prevent the door from warping over time. If ST is 3 3/16 feet, PS is 7 feet, and the measure of angle PTQ equals 67. Find the other thing.
What?
Page 422.
What?
I just read the directions for check understanding number 1.
I thought you were down at the application.
You can tell me the measure of side QR.
7.
Correct, 7 feet.
Are we ready to start?
Oh, if you'd like to. Who can tell me the measure of SQ?
3/13. 3/13.
No, it would be 3 3/16 squared.
Y squared.
Because ST is half of SQ and you ask for SQ in that.
So I'm going to square it.
You multiply it by 2. Well, you times it by 2, not squared.
Times it by 2, not square. All right. I like what you're thinking. So what's the answer? 7 and 5/8. Very good. Let me ask you this. How many people, if you had to do this, would go, okay, 16 times 3 is 48 plus 13, so that would be 61/16, right?
I would type it in the calculator.
And then you're going to times it by 2. Would you guys agree with me that 3 and 13/16 would really be like 3 plus 13/16?
No.
You wouldn't agree with that? 3 and 13/16 would be equivalent to 3 plus 13/16.
Oh, yeah.
Then use the distributive property. What's 3 times 2? And when you multiply 13/16 times 2, of course,
You get 26 over top.
you get 13/8.
7 and 5/8. Wait, how'd you get 13?
Well,
Oh, you crossed.
cross canceled.
Yeah.
And 13/8, well, that doesn't make sense to say a mixed number, so 8 goes into 13 one time, so add that 1 to the 6 with 5 left over, and that's how you get 7 and 5/8. Good. Who's got the measure of angle TQR? Yes. Angle.
Oh,
I hear an OO.
I got this. Oh, no, I don't. I got this.
Is it 45?
Nope.
Let me break out the hand again.
67.
Nope.
134.
Nope. You guys seem to be struggling.
23?
Not according to the book.
Okay.
P, Q,
33.5.
R, S,
It's 67.
T. Hold on.
33.5.
All right. PTQ is 67 degrees.
56.
Okay. And we want to know the measure of TQR. Guys, let me ask you this. How much is
113.
QTR?
67.
How much is angle QTR?
Alright, 113.
113.
Guys, let me ask you this.
33.5.
Stop. Since it's a rectangle, the diagonals are what to each other? Congruent. But since it's a parallelogram, the diagonals do what to each other?
Cut them in half.
Right. So can you guys agree that TQ is congruent to TR?
Yeah.
which means that the angles opposite those are also congruent. So we simply say that's 67, because that's what these two have to add up to be, divided by 2. And Mr. Chase was correct. It is 33.5 degrees.
I multiplied.
Wait, I thought it would have been 67. Wait, never mind.
Hey?
Did you say that down?
1 minute.
We do? Okay, but I'm in the middle of teaching something important.
You gotta teach her 30 seconds.
Well, maybe I'll have to hold you a couple minutes after the bell to get the rest of my work done.
Oh, yeah, let's go.
Actually, just guess.
Okay. All right. We'll pick it up when we come back.